Get ready for a cosmic event that could redefine our entire understanding of the universe. Betelgeuse, the massive red giant star located on the outer edge of our galaxy, has begun emitting unusual signals that indicate it might be on the verge of a dramatic transformation. With the help of advanced technology, such as the James Webb Space Telescope, astronomers have uncovered some unsettling facts about this colossal star, and the implications for our future are truly profound. Astrophysicist Brian has sounded a serious warning, as we are left wondering if we are about to witness an extraordinary and destructive event that could forever change the night sky. Will Betelgeuse soon explode into a supernova, marking the end of its life in an unimaginable burst of energy? Let's explore this incredible mystery and discover what is happening with Betelgeuse, a star that has long been both a source of fascination and concern for astronomers and stargazers. Betelgeuse, located in the constellation of Orion, is a red supergiant star, truly massive and ancient in ways that are almost beyond our understanding. It is well known for its unique reddish glow and its fluctuating brightness. However, recent observations have raised eyebrows, especially after the discovery of significant shifts in its behavior. At about 764 times the size of our Sun, Betelgeuse is an enormous star. To put this into perspective, if it were to replace the Sun, its surface would extend far beyond the orbit of Mars, engulfing not just Mars, but also Mercury, Venus, and Earth. Its sheer size gives us an idea of the massive forces at play within this celestial body. But size is not the only thing that makes Betelgeuse stand out. The star is nearing the end of its life cycle, having entered a phase known as the red supergiant phase, where it is expanding and cooling after billions of years of fusing hydrogen into helium at its core. Betelgeuse's age is equally remarkable. Estimated to be around 8 to 8.5 million years old, it may seem young from a human perspective, but in terms of stellar lifespans, it is ancient. Stars like Betelgeuse have much shorter lifespans compared to smaller stars like our Sun. Its current phase marks the final stages of its existence, as it has undergone a dramatic transformation from a hot blue star to the cooler red supergiant we see today. As it burns through its nuclear fuel, Betelgeuse is gradually losing mass and undergoing profound changes within its core. One of its most distinctive features is its red hue, which contrasts with the bright yellow light emitted by stars like our Sun. The surface temperature of Betelgeuse is relatively cool, around 3,150 K, compared to the Sun's 5,500 K. This cooler temperature results in the star's red appearance, which provides astronomers with valuable clues about the internal processes and evolutionary state of the star. Interestingly, ancient records suggest that Betelgeuse's color has shifted over time. Roman and Chinese texts indicate that the star appeared yellow about 2,000 years ago. By the 9th century, Arabic astronomers observed its reddish tint. This color change is not just a curious detail. It offers important insights into the star's long-term evolution and the dynamic processes at work within it. Another fascinating characteristic of Betelgeuse is its variable brightness. Classified as a semi-regular variable star, its brightness fluctuates over time in a predictable cycle, with variations that occur every 400 days, alongside longer changes over a period of about 5 years. These cycles of dimming and brightening have been recorded for centuries, but what makes Betelgeuse particularly intriguing is its occasional irregularity. Unlike many stars that follow consistent patterns, Betelgeuse sometimes deviates from this cycle, displaying fluctuations that current models of stellar behavior cannot fully explain. In late 2019, Betelgeuse attracted global attention when it began to undergo an unprecedented dimming event known as the Great Dimming. This sudden and dramatic reduction in brightness was so significant that even amateur astronomers in areas with light pollution were able to observe it. At its peak, Betelgeuse was losing light at a rate of 0.01 magnitudes per day, reaching its lowest point in February 2020. This sudden dimming raised concerns among astronomers, leading them to question what it might mean for the star's future. However, there's an important factor to keep in mind when observing stars like Betelgeuse. We are not seeing them as they are in the present. The light we see from Betelgeuse actually takes about 725 years to reach us, meaning that when we look at it, we are seeing the star as it was centuries ago. This phenomenon, known as the light travel time effect, applies to all stars beyond our solar system. As a result, any changes in Betelgeuse's brightness that we observe today may have actually occurred in the past, making it difficult for astronomers to assess the star's current state. The implications of this time lag are critical, particularly when considering the possibility that Betelgeuse might be about to undergo a supernova explosion. If the star were to explode, we would only become aware of the event centuries after it had already occurred. This paradox presents a unique challenge for astronomers studying Betelgeuse, as they must rely on historical data and make predictions about its future behavior. During the Great Dimming, researchers led by Andrea Dre at the Harvard-Smithsonian Center for Astrophysics used the Hubble Space Telescope to study the outer atmosphere of Betelgeuse. Their findings revealed that the star was losing material at extraordinary speeds, around 200,000 kilometers per hour, leading to the formation of a dust cloud that partially obscured the star's light. This mass loss and the subsequent dust cloud sparked speculation about whether the dimming was a precursor to an even more catastrophic event, such as a supernova explosion. Theories about the cause of the dimming abound. One hypothesis suggests that Betelgeuse is going through a phase in the supernova process, nearing the end of its life. Another theory posits that dust might be obscuring our view, as Betelgeuse is known to shed material that can form dust clouds. A third explanation involves changes in the star's photosphere, which might cause its apparent brightness to fluctuate. Further analysis revealed that the dimming might have been triggered by a massive ejection of material from the star, which cooled and formed a dust cloud that blocked the star's light. This ejected material was likely superheated plasma from a large convection cell on Betelgeuse's surface. The scale of this ejection was staggering, about 400 billion times the mass of a typical coronal mass ejection from the Sun. This massive release of material raised alarms across the scientific community, suggesting that Betelgeuse could be in the final stages of its life, possibly preparing to explode in a supernova within the next few millennia. The big question remains: when will Betelgeuse go supernova? Some astronomers believe the event could occur in the next few tens of years, while others speculate that it might take up to 100,000 years. Regardless of the timeline, one thing is certain. Betelgeuse is a star in the twilight of its existence, and we may be witnessing its dramatic, explosive finale. Should Betelgeuse explode in our lifetime, it will be a core collapse supernova, a cataclysmic event that occurs when a massive star can no longer sustain its own gravity and collapses under its weight. The resulting explosion will release an unfathomable amount of energy, more than the Sun will emit in its entire lifetime, and it will briefly outshine the Moon, making it visible even during the day. Fortunately, despite Betelgeuse's proximity to Earth, we are safe from any immediate danger. However, the scientific value of observing a Betelgeuse supernova would be immense, providing us with unprecedented insights into stellar evolution, element formation, and the nature of the universe itself. As we await this extraordinary event, the night sky may soon be transformed by a cosmic display, reminding us of the dynamic and ever-changing nature of the universe. Betelgeuse's final act promises to be a spectacular reminder of the immense forces at play in the cosmos and the incredible scale of the celestial drama unfolding before our eyes.